And I am back. So this is the third video for chapter two. I think I'm going to do a little one for the review also. So there'll be four videos for this one. We got to do graphs and biases. So I like how people always say there's all these biases with stats and all this stuff like that. So I keep getting tons of emails this morning, which is totally fine. I'm just going to make sure nobody's like crying or freaking out about it. No, we're good. We are good. Cool. But email me. If stuff's too hard, stuff's weird, shoot me an email. So I'm going to be doing graphs and biases 2-3. So one of the major things that they do, they always change the scale. I change the scale too. Don't get me wrong. I totally change the scale, but I change the scale so you can see it clearly. But you should always be looking at the axes for every graph because let me share my screen. It could mean a lot of different things. So what am I trying to say? So yeah, lots of emails. What a surprise. So here I'm in 2.3 graphs and biases. And I'll pull this over and we'll do the problems. But basically, if we have a graph and let's say it's from 0 to 100%, right? And everything is down here and it's like productivity or something like that, whatever it could be, like whatever this is, productivity, and everything is like down at like 10% or like 20%, right? Whatever this is, they can make it from 0 to 20% and be like, "Ooh, look at our productivity. It's all here. It's so much bigger," right? So they do this stuff a lot. Same graph. The scale is changed. It's like one of the worst things for bias, or to try to skew the results. So that's what I'm going to keep in mind. We'll look at the chapter, and I'll get into it after that, but should be pretty clear. Hopefully this stuff is useful. If you don't like the videos, you need more help, just reach out to me and I will help you. So we're going to look and see what they have in this chapter. I did tons of stuff for the first video is like an hour. So you don't have to watch the whole thing. But here we go. Graphs that enlighten and graphs that deceive. So that's their title. I shortened it to just graphs and biases. So let's see what they got. What do we start with? Oh, you get types of graphs. The first one's a dot plot. I like dot plots. So here's a good way I think about it. I think about lines, bars, and pies. Pi is used for like budgets, percentages, right? Ooh, that's an ugly looking pie. So this one you're going to use for like a budget, a percentage out of a total. Okay. Now bar graphs are great if you want to compare groups for like comparing groups. Like let's say this is the men and this is the women. So this is like great for comparing groups, the bar graphs. Man, my pen is going crazy today. And then what is a line graph good for? It's good for to like show trends or like one variable over time. There are other ones, one variable over time. All right, so they're talking about dot plots. So what is a dot plot? Dot plots are okay. They just kind of show you the shape of the data. This is a right skewed graph, and that's the dots. The dots show you every data point. That's a good thing about the dot plot, every data point, which is kind of nice. Usually possible to recreate the original list. Yay, there's a data point. This one is, I would say it's multimodal, like trimodal. How many are the most, or like tri-peaks, right? You want to think of it, it's not modal, like how many peaks it has, I would say multi-peaks, but this is pretty normal distribution. I would go with normal in this one. Okay, then we got stem plots. Stem plots people mess up all the time. And I don't know how often they're used, but it's okay. So they're usually called stem and leaf. I haven't seen this in a while. So we got our stem and we got our leafies. Now, they have theirs with tens, but basically if we have data like 42, 43, 44, 50, 50, 56, 57, it doesn't matter what it is. So the stem is usually the highest. The stem is always like the highest I guess like value, like it's either the tens place or the hundreds place or whatever highest values are. So ours is going to be fours and fives, and our leaves are going to be all these little numbers. So it's going to be 2, 3, 4, 0, 0, 6, 7. That means I have 42, 43, 44, 50, 50, 56, 57. Why is it used? I don't really know. I think it's just used to show like all the data in a different way that's not a table. It reminds me a lot of scientific notation, but that's what the stem and leaf plot is. Here's a line graph. As I said, it's showing things over time, which is nice. I like it. It's usually a trend of something. So this is shipments over time. Notice that this line graph has only one variable that you're looking at. That's usually it. And you're not comparing groups. All right, let's see what else we got. We got the bar graph, which is easy. So the bar graph is usually comparing groups together. We got the Pareto chart, which I haven't heard in a long time. So it's categorical data with the added stipulation that the bars are arranged in descending order according to frequencies. So Pareto, we're going down. Nothing too crazy about that. And it's categorical. So it's always, so this is your Pareto. Shifting down, important to categories. Let's look at one. Ta-da. Oh, and then we have another one that doesn't fit. I like that. That's pretty cool. This was the data that we got from it. Here's the pie chart. And the pie chart's always for percentages, which is really nice. Highlight error, it's like when you want to show percents. I usually just use it for budgets. I think this one would be better for a bar graph, but that's just me. People who wish to that's a funny joke. Gotta love the math jokes. And then we have a frequency polygon. So this uses line segments connected to points located directly above class and midpoint. So it's got these like little pieces on it. So here, we've got these extra pieces here. So what does it do? It's very similar to histogram, but uses lines instead of a frequency polygon is literally a frequency table if you want a line instead of a bar chart. That's okay. I like the bars better. Okay, cool. Okay, so the first thing for biases, now we're talking about biases, they said a non-zero vertical axis. They're just changing the scale. So if they change the scale, it is bad. It doesn't start, so the placebo should be further down. Yeah. And also this one, it's not even out of 100%. So percent experiencing nausea, you can see like, oh my God, look at the difference, but it stops at 10 and only goes to 24. So like, you should always look at the scale. Look at the scale for all these, okay? Oh, and pictographs. It's where they use images instead of bars or anything to kind of like show the data. Do I have an example? Yeah. How useful is this? I don't know. It's like if you're trying to sell something, if you're in advertising, it might be a good sense to use the product yourself for the pictograph, but that's okay. Just hold on one moment. So I don't know how great they are, but it's up to you. And we're at the end. Cool. It's saying which ones they have. So StatCrunch has the dot plot, the stem plot, and scatter plot. So Excel doesn't have a couple of those, but they've got the Pareto charts. Ooh, fancy. So I said I'd use Excel this time. I used StatCrunch last time, but we'll use whatever. I want you to get comfortable using whatever is most comfortable for you. I know that on the homeworks, the StatCrunch is built right in, and StatCrunch is built right into your test. But it's up to you. If you really like Excel, use Excel. All right, let's get after it. We're doing 2, 5, 10, 12, 14, 18, 20, or just 2, 5, 8, 12. I said I would do a ton of these for you for each one, and that's what I'm going to do. So let's get into it. So let's start with number 2. All right. Stem plot. Construct a stem plot of the data listed in exercise 1. If only given a stem plot, if given only stem plot, can the original data values? Yes. So what is the stem plot? I call it a stem and leaf. I could be crazy. So basically to make the stem plot, I would put them in order, but here we go. Here's the stem plot. The smallest one you can see is 54. And it's just in groups of 10. So I'm just going to do 5, 6, 7, 8, 9. I'm going to draw a line. So the first one is 54. Boom, we used it. What about my 60s? I have a 68. I do have 70s. Well, I start with 0. 0. Then I have 76 and 79. And then we're in the 80 range. I got 82. Oh, I lied. 81 is first. You just have to do them in order. 81. And then I have 82. Do I have any more 8s? Nope. And then we just have 190, and it's a 98. It can kind of give you, like, if this was in bins, like if this was in a range, right, we would see that this is pretty symmetrical, right? Isn't that kind of cool? You can kind of be like, ooh, this looks kind of symmetrical. And yes, you can get all the data from this. You just have to rewrite it. It gives you every data point. All right, well, that was 2. Let's check out 5. All right, we're making a dot plot. Pulse rates listed below in beats per minute. Oh, I actually have a really great statistical piece. I think I'm going to add it in for extra credit. If you want to do an extra, I know there's tons of work in here, but I think I'm going to add an extra credit assignment about beats per minute. I think I'll do it after test 1, especially if people bomb it. So I'm going to make you a really cool music-based extra credit project. Hopefully that's fun for you. Okay, so listed below are the pulse rates in beats per minute of females from data set 1 in Appendix B. All of those pulse rates are even numbers. Is there a pulse rate that appears to be an outlier? What is that value? I would go with 36. It's over 10 away from everything else, which is totally makes sense. But they want us to make the dot plot, so I might as well make the dot plot. To me, the outlier is 36 because it's so far away from everything else. If there was like a 208 beat per minute, like BPM, or pulse rates, are like, well, they wouldn't be alive. But yeah, if it was that, this is probably a runner. If your BPM so slow, it means you like run a lot and things like that. So my outlier is probably 36, but let's make it. And let's make it on, you have to do a dot plot. I think we can only do dot plots in StatCrunch, so let's pull it up. Here's my StatCrunch. Let's go to data sets, and we want pulse rates. There's no pulse rates. Oh God, because there's 5,000 pages. Crazy. Here's the pulse data. Oh, here it is. Male and female pulse rates. I'm pretty sure this is the one we need. I don't know where it happened. Okay, I don't know what happened there. But here's the pulse rates for men and women, but it gives us more than what we have in this little chart. Oh, because they don't want us to do the whole thing. So I'm just going to do a new one. So I'm just gonna go to StatCrunch and I'm just gonna make a new thing. So we're in Pearson, I click StatCrunch. And I'm just gonna make a new one with this data. So let's go to the website. And I just want to do just open StatCrunch. Because the one they gave us had like way too much more than what we needed. So I'm just gonna make one. It's not crazy. So here we go. We got pulse rate women. Let's drop them in. So here we go. 80, 94, 58, 66, 56, 82, 78, 86, 88, 56, 36, which I think is the outlier, 66, 84, 76, 78, 70, sorry, 64, 66, 78, 60, and 64. Cool. So I'm going to go to graph. I'm going to go to dot plot. I'm going to click this one. It's the only thing we got. I'm going to click compute. There it is. So how far away is that one? That's the data point that's super far away. There's the dot plot. You can see the one with the mode. It's bimodal. That means we have two of these numbers. So 66 and 78 are the two modes. They're the two ones that are the highest. Okay, cool. Well, I'll do another one of these. All right, number 6, or what was next? 8, and then 12. Refer to the data listed in exercise 6. Okay, this data. Identify two values that are closest to the middle when the data are sorted from lowest to highest. This is also used to find the median. Cool. Well, we know the middle is just n plus 1 divided by 2. That will give us our middle number. This is the formula for median. Remember, median's like the middlemost root. It's what they did when they were trying to find like the passage through time and stuff like that. So to find the middle number, we can list them all and we can literally click median. So let's use Excel for this. Why not? I'll go back and forth for tons of these just for the fun of it. So let's do this one with, if I hit plus, I get a new list. And I don't need a comment. So I'm going to put these in. I'm going to get the middle. All right, so here we go. Notice that this one, I don't have the variables on top, right? 62, 70, 70, 76, 72, 90, 88, 86, 70, 60, 66, 78, 68, 82, 70, 78, 82, 84, 74, 76, 90, and 60. And the last two is 62 and 64. I always double check. So here I got 24. So this should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 2 is 24. We got them all. First thing I'm going to do is I'm going to sort these. From smallest to biggest. We can see our middle numbers right there, or we can literally just use the program. I can literally do equals median from this one to, we already know it's 24, but you can click down here. Where's your middle number? It's 73. Is that nice? So because I have 24 numbers, I'll show you how the formula works. So 24 numbers plus 1 divided by 2. What's 25 divided by 2? It's between 12. It's 12.5. So this means our middle number is going to be 12 and 13. So if we go back to our data, we'll see that between 12 and 13, we go back to our data, we can see that between 12 and 13, I'm between 72 and 74. See? So what is right in the middle of these two numbers? 73. That's how you can use the formula to figure it out. All right, let's do one more, and you should be good to go. Sorry about that. I just have tons of stuff open here. Book 9. There's the StatCrunch. And here's where I'm working. Nice. And let's do 12. Let's do one more. So the last one I'm gonna do is 12. All right. Construct a Patero. Oh, I'm not going to draw you this. So you can, no, the Pareto chart. Pretty sure the Pareto chart is just a histogram with lines instead of bars, right? I'm pretty sure it's just a, oh no, so it's Pareto is the histogram in descending order. So you have to start from the biggest to the small. So in a survey, seeking a job, who were asked thank you notes after having a job interview. Results were as follows. 40 said the person they spent the most time with, 396 said everyone they met, 40 said the most senior person, 50 said the person that thank you notes, and 10 said they don't send you thank you notes, and comment on the results. So I got to start with the highest one and go down. So the biggest ones, obviously, so we're talking about getting a job. So getting jobs, always put a title, thank you notes. We're asked this after a job interview. 40 said that only the person you spent, everyone you met. So this one's going to be everyone. And we have to go from 0 to 400. So really think about your range. So 0 to 400. What should we make this thing? So we can go 0, 50, 100, 150, 200, 250. Oh, I ran out of space. So 0, 50, 100, 150, 200, 250, 300, 350, 400. So the first one is 396, almost at fully 400. That's for everyone. The second one is these are the same, so it doesn't matter the order. So 40 said most time with, so most time with is 40. A little bit under the 50. The next one said the senior person, so like the person most in charge. And then 15 said the person best conversation. So the best conversation is 15. And 10 said that they don't. They just don't do it. So none. So that's 10%. Comment on the results. Well, one, this is obviously talking about a right skew here. It's an overwhelming amount that they send it to everybody. That if you send a thank you note after job interview, you should send it to just not one person, but everybody. So that's my comment on the results. Hopefully this was helpful. Good luck. Let me know if you have questions. I'm gonna do the review, but keep it up. I'm sure everybody's doing great. This will be posted, and take care.